Now we're going to look at another principle we're going to use to solve some linear equations. Now remember, the key to equation solving is this. Whatever you do to one side of the equation, do it to the other. Let's look at our first problem. We have negative 1/8 x equals negative 2. Again, the goal in equation solving is to isolate the variable. In this case, it's x. I see right now I have a little problem because I have 1/8 right next to the x. So what I'm going to do is choose to multiply both sides of this equation by the number 8. Now let me first of all rewrite the equation so that when we do our little check, we'll be able to see what our original equation was. So as I just said, we're going to multiply this left-hand side of the equation by 8, but whatever we do to one side of the equation, we better do it to the other. So we'll multiply that side by 8 as well. 8 times 1/8 is simply 1. 1 times x, we get our x there. Equals, on the right-hand side, negative 2 times 8, negative 16. So x is equal to negative 16. Again, we rewrote the original equation so we can do our check. So now we're ready. We take the negative 16, substitute it up into the original equation. Is 1/8 times negative 16 equal to negative 2? It certainly is, so we are correct. Let's try another one of those problems. Look at our second equation here. Here we have 6x is equal to 50. Now, as I just said, whatever we do to one side of the equation, we're going to do to the other. Here, we multiplied both sides by 8 to eliminate the 1/8. Here, what I'd like to do is get rid of the 6, and I would like to divide both sides by 6. You might be saying to yourself, hey, wait a minute. I thought you said this was called the multiplication principle. It is, but remember, if I divide by 6, that's the same thing as multiplying by 1/6. So however you look at it, you can look at it as multiplying by 1/6, or as I like to think of it, dividing by 6. You're actually using the multiplication principle. But the key to remember with any equation solving is this. It's just whatever you do to one side of the equation, do it to the other. So as I said, I'm going to take this equation and divide both sides by 6. When I do, I can see my 6's divide out, and I'm left with x equals, and now on the right-hand side of my equation, I have 50 over 6. I'm going to have to reduce that somehow, 50 over 6. Common factor between 50 and 6, 2. 2 divides into 50 25 times. 2 divides into 6 3 times. So x is equal to 25/3. Now again, when you like, you can always check to make sure you're correct by taking your solution and substituting it back into that original equation. You should always get a true statement. That wasn't too bad, was it? Are you ready to try a couple of new problems with some new ideas? Let's look at our next equation. In this equation, we're going to look at negative 27x equals 54. Now again, when we look at our equation, we want to isolate that x. I see that right now I have a negative 27 times x. To get rid of that negative 27, I'll simply divide both sides by negative 27. Because remember, we can do whatever we want to an equation as long as we do it to both sides. Negative 27 divided by negative 27, 1. 1 times x equals, now the division on the right-hand side is 54 divided by negative 27, which is exactly 2. But since we have one negative sign, I get negative 2. Again, if you want, make sure and just do a little check by substituting in the value you found, negative 2, in for x in your original equation. And notice this is an easy one. Negative 27 times negative 2 is definitely positive 54. So we're done. Let's try another one. Let's look at negative x is equal to 36. Now in this one, you might be saying to yourself, I don't know what to do. There's not much here. Well, you're right. We almost have x on the left-hand side of the equation. The problem is we don't want x over here we don't want negative x over here. We want positive x over here on the left-hand side of the equation. So let's think. How can I make this negative x into a positive x? Well, think of the multiplication principle that we've been utilizing thus far. If I could take this left-hand side and multiply this negative x by a negative 1, that would make this into a positive x. So again, let's go ahead and rewrite that original equation. And we're going to multiply both sides of this equation here by negative 1. Now remember, the key to equation solving, and I can't emphasize this enough, is it doesn't matter what you do to the equation. Whatever you do to one side of the equation, do it to the other, and you'll be safe. Even if you add or subtract the wrong number, as long as you do it to both sides of the equation and do the arithmetic correctly, eventually you'll get to the right answer. So we have negative x times negative 1, or negative 1 times negative x, which we said is positive x, equals, on the right-hand side of my equation, negative 36. Now again, just for checking's sake, we can take the negative 36, substitute it back into my original equation. Is negative 36 equal to positive 36? It certainly is. So our check is complete. Well, that wasn't too bad. I think we're ready to try a few more. Let's try a couple of new types of problems. Not new. Let's still use here this multiplication or division principle, whatever you'd like to call it. Let's look at negative 51 equals 6x. Now again, I see that I have the x and it happens to be on the right-hand side of the equation. Is that going to change anything? Well, thankfully, because of the reflective property, that answer is no. For instance, if I wrote here x equals 2 or 2 equals x, I'm really saying the same thing. So it doesn't matter what side of the equation the x ends up on. The key is x must be isolated. You must do whatever you do to one side of the equation, do it to the other. That's the other key. So here we go. We see the x here. We want to isolate it. We have 6 times x. So what we're going to do is divide both sides by 6. And whatever we do to one side of the equation, we do to the other. So if I divide here the right-hand side by 6, then I better divide the left-hand side by 6. Now, what do we have left? We have negative 51 over 6 is equal to, in this case, you see the 6's divide out, and we're left with x here on the right-hand side. Now, don't be too hasty. Don't say, okay, x is equal to negative 51 over 6, because we want to make sure that all of our solutions are in simplified form. So look carefully at this fraction. Now, this may be one that you're not too familiar with, so let's study it carefully. 51 and 6. 51, let's go ahead and write these guys as the product of prime factors. So 51, we're going to write, oops, I was going to write 51 again. We won't do that. 51 happens to be 3 times 17. And in the denominator, we know that 6 is 2 times 3. So once we do that, then we can see that the 3's divide out, and we're left with negative 17 all over 2. Now, to make sure you're correct again, you can take this negative 17 over 2, substitute it in for x in the original equation, and you'll see that indeed the answer is negative 17 halves. Now, let's just recap here. The key in this multiplication or division principle is this. Whatever you do to one side of the equation, do to the other. If I choose to divide one side of the equation by 6 to eliminate the 6, just make sure you do the same thing to the left-hand side of the equation. If you can keep this one basic principle in mind, it'll help you avoid many mistakes in solving your linear equations.